How do you cut stone with millimeter precision without metal tools? That question has haunted researchers for decades, and the more closely they examine these ruins, the less comfortable the answers become. Scattered across a high Andean plateau in western Bolivia, at nearly 12,500 feet above sea level, lie the broken remnants of Puma Punku. What lies shattered here defies easy explanation. This is not a place that looks ruined. It looks deconstructed. The stones fracture in straight lines. They scatter in patterns. And when you examine individual blocks up close, what you find stops you cold. The cuts are exact, unnervingly so. Puma Punku is part of the Tiwanaku complex, a pre-Columbian civilization that flourished near Lake Titicaca from roughly 500 to 1000 CE. Tiwanaku was sophisticated. Long-distance trade networks, engineered agriculture, monumental construction. But Puma Punku raises questions its most studied scholars haven't resolved. The site is dominated by enormous H-shaped andesite blocks, some weighing up to 20 tons. The great sandstone platform slabs go far heavier, the largest estimated at 131 tons. The sandstone was quarried roughly 10 kilometers away. The ornamental andesite pieces traveled far further, up to 90 kilometers, likely ferried across Lake Titicaca by reed boats. Moving any of it without wheeled vehicles or draft animals through this altitude required extraordinary organization. But the how of transportation is only half the story. It's the surface work that leaves researchers without clean answers. Examine these blocks, and you'll find drilled holes, perfectly cylindrical, consistent in diameter, bored into some of the hardest stone in the region. Channels with right-angle precision, interlocking notches, recessed grooves, flat surfaces, ground smooth enough to reflect light, tolerances within a single millimeter, across spans of several feet. The official consensus holds that the Tiwanaku used stone, bone, and possibly bronze tools, along with enormous reserves of time and skilled labor. That explanation is credible. But here is what makes Puma Punku genuinely difficult: the scale and the repetition. These aren't isolated showpiece carvings. Dozens of blocks carry the same standardized cuts, the same angles, the same board diameter. This leads us to a startling conclusion that whatever produced this precision was reproducible. It was a system, not an accident of craftsmanship. Some researchers propose the Tiwanaku used templates or jigs to physical guides, ensuring uniform dimensions across multiple blocks. Credible hypothesis. But no such templates have been recovered. The evidence remains inconclusive, yet it suggests engineering planning we've only begun to appreciate. The blocks were also designed to interlock without mortar. No cement, no binding material at all. Geometry alone held the structure together. That requires not just skill with a chisel, it requires structural calculation across the entire assembly. But what that assembly was for is where things get stranger still. Archaeoastronomers have noted that alignments at Tiwanaku appear oriented toward solstice and equinox sunrises. Whether Puma Punku was engineered around these alignments is still debated. But its primary axis appears deliberate. It makes one wonder if the intent was far more deliberate than we assumed, not just ritual, but encoded knowledge built in stone to outlast the culture that made it. What makes this especially troubling is the condition in which the site was found. When Spanish chroniclers first documented the ruins in the 16th century, Puma Punku was already destroyed. The Inca considered Tiwanaku sacred, yet Puma Punku was already rubble when they arrived. That places the destruction before roughly 1100 CE. The cause remains unknown. Whatever ended Puma Punku ended it completely. The largest stone block at the site weighs an estimated 131 tons. Getting it here required either a massive coordinated labor force or sophisticated use of ancient waterways. Recent research supports the waterway hypothesis. The lake's shoreline may once have reached far closer to the site. That partially explains transport. But it deepens the question of who was directing it. The Tiwanaku had no known writing system, no surviving records we can read. What we have are the stones. And the stones are not saying anything simple. That silence is the quietly unsettling part. We're looking at the output of a highly capable engineering culture, and we have almost none of their own words about why they built it. We're reading intention from objects alone, and these objects suggest an intent that still outpaces our understanding. Researchers continue working the site. Ground-penetrating radar has indicated possible buried structures, chambers, walls, artifacts, untouched for 1,000 years. Each season brings new data and new questions. These ruins don't demand attention the way a pyramid does. They ask for it quietly, in angles and bores and fitted edges lying half buried in dust. The scale of what was built and what was lost settles over you slowly. Because somewhere between the tool marks and the tolerances, between the missing records and the 131-ton stones, is a gap in our understanding that keeps proving wider than we thought. Some questions don't get answered, they just get more precise. What do you think the Tiwanaku were truly capable of? And what do you think we're still getting wrong about them? Leave your theory below.